Hello students, here we are with the topic known as the components of vectors. Now component means, okay, so if you are talking in terms of a machine, components basically mean parts of machine, isn't it, right? So when we are talking about components of vectors, it is something that vectors are made up of, right? Now in a previous video, we have talked about representation of a vector, that is a1 I cap plus a2 j cap plus a3 k cap, right? This is k cap, nice. Now, when we are talking about in 3D, so just assume that vector is a diagonal of a cuboid having length, breadth and height as a1, a2 and a3. In this particular scenario, the length is a1, the breadth is a3 and a2 is the height, right? So, when we are talking about the components, isn't it, can you say that it is just, so if we are tracing this particular point, isn't it that we start from origin, come till this point and then start moving upward, come till this point and then start moving forward and we'll reach this particular point. Isn't it the case, right? So we can clearly see that it is a1 I cap plus a2 j cap plus a3 k cap. That's what we depicted in the previous video as well. Now we can clearly see that in x direction, the length of this vector is basically a1. So the component or x component would be a1. Similarly, y component would be a2. And z component would be a3. Now having said that, what if that's a 2D vector, only two dimensions are available in this particular vector? We can say that it will be x and y. So in x direction it would be a1 I cap and in y direction it would be a2 j cap. So this particular vector can be written as, let's say, a vector is equals to a1 I cap plus a2 j cap, right? We avoid doing this for components because this is treated as just magnitude and the direction is given by I cap. Nice. But what if no a1 a2s are given, rather just the magnitude of the vector a is given? So the magnitude of vector a is a. How do you find the component of vector then? It's very simple. You can see this particular triangle and a is the hypotenuse of this particular triangle. So this would be the perpendicular and its length will be a sine theta. Why so? Because sine theta is equals to p upon h. Hence p is equals to a into sine theta or h into sine theta. Similarly, this particular length would be a cos theta, isn't it? Right? So we can write this particular vector as a cos theta I cap plus a sin theta j cap. Now, if you represent it like this, this is also correct. But if you want to represent it like this, that's also correct because we are writing it as a cos theta I cap plus a sin theta j cap. So a cos theta I cap plus a sin theta j cap gives us the a vector, right? Now, what happens? Listen to me carefully. What happens if the angle is not with x-axis? What then? Or can we say that it's always going to be, the x component is always going to be a cos theta and the y component is always going to be a sin theta? No. See here, what I have written is theta is the angle with axis, not x-axis, any axis. So let's say I have created another axis here. The vector is in the fourth quadrant and here is the x-axis and here is the y-axis. But now this time the angle is being given with y-axis. So this will be a cos theta and this will be a sin theta. So this particular vector can be written as a vector is equals to a sin theta I cap minus a cos theta j cap. Now you are going to tell me why I have written this minus.